I'm Adam Erb. I work on Cash App. This room is packed. Yeah, this is still the Kill XML talk. I changed the name, and I'm just very bad at telling people when I make these changes. But yeah, it's about Contour, a project I've been working on at Cash App. So I kind of like come in from like a 1,000-foot view. This is like I feel like this is like a very rough overview of like the like correct way of building stuff, building apps nowadays. You kind of have like over on the left your user interface. It's going to be like a series of views. We think a lot about like presenters and controllers. We like try to isolate our logic into these like kind of pure units that we can test. That's usually going to be like coordinated by some sort of like navigation framework. It's like it'll either be like something Google's made or something in-house, kind of custom. Those presenters and controllers, they're probably going to talk to persistence layer. That's probably going to talk to a networking layer. That's probably going to use some serialization format to talk to your server, you know, out in the cloud, Kubernetes. And this is good. Like this is all we've put a lot of thought into this kind of way of building our app. But if your application looks like shit, it doesn't really matter. All of us work in pretty competitive parts of tech, and users are fickle. If your UI doesn't look good, they may go to a competitor. So kind of the underpinning of this talk, which I kind of like to rant about, is that like I think front-end development really matters. And when I talk about front-end development, I mean like truly like the stuff that is drawing pixels, that is laying out. I think that's something we should invest in. So far, we've invested in a lot of application development in the Android community and in my company. We've built like database technologies, networking technologies, different ways of serializing stuff, an insane amount of like really sophisticated tooling. But like in terms of like the current state of Android UI development, I kind of feel like it's remained the same almost from the start of Android. Like the way we build UIs now is kind of the way we have built them for like 10 years. Like we're still declaring stuff in XML for declaration and configuration. Like we're still in the 90s, kind of like, you know, HTML and like kind of like pushing CSS into it. We're using like constraint layouts, relative layouts, like or just like heavily nesting stuff. Kind of awkwardly like trying to push and prod views into the right position. And we have kind of like ad hoc tooling. It's very sophisticated, but like we're still like generating these weird R classes, like building IDs like kind of on the fly to map between code and XML. So that's weird. Styling, I think like it was kind of brought up in the last talk as well. Like styling is kind of awkward. And inspection is okay. This is like what you see when you go to Layout Inspector on the app I work on. Like, it's pretty broken. It's not really giving you a whole lot. So, like with all this stuff in mind, I've kind of been working on a library that we've been using internally called Contour, and yeah. And the idea with it is I want to try to push a new way of thinking about building views. To build combined layout. So Contour, Contour does this. It provides a layout DSL to chain layout directives to kind of dictate the way views are supposed to be laid out and positioned in your app. And importantly, it's about building dynamic views, which can kind of like look at the state of your app during layout and like actually make intelligent decisions based on that state. So yeah. Interestingly enough, I think it's almost more about what it abandons than what it is. For one, it kind of discourages the use of XML for view declaration and for layout. Yeah, it is compatible with XML. It's fully compatible with the rest of the normal Android world, but you are by no means required to live in that world if you don't want to. It tries to replace constraint, relative layout, heavy nesting with kind of a simpler layout DSL, which is tries to, as closely as possible, mimic the underlying layout APIs. And it tries to get away from kind of this ad hoc tooling by living in a pure Kotlin world and really just avoiding the interface between XML and Kotlin or Java altogether. So to actually start using this thing, kind of your entry is going to be by subclassing contour layout. The class that subclasses this will kind of act as the window or the canvas on which you are positioning and describing views. So to declare stuff in Contour is so far totally vanilla Kotlin. You can set up views by calling the constructor directly, passing in a context, and then using the Kotlin apply extension function, you can kind of declaratively bind data to the view or set styling, stuff like this. An interesting thing right off the bat with this approach is that you can grab references to the views as you build them up. So for one, right off the bat, find by view by ID is not really needed anymore. You have your references right there available to you as you build your view. A cool byproduct of this as well is that data binding kind of comes for free. You don't have to set up these weird kind of lambdas within your XML or find view by ID, get the reference and apply stuff to it. Instead, as your view is being created, you can look at maybe a data transfer object and on the fly start loading an image or applying a tint color. At the bottom here, at the very bottom of this statement is stroke width equals 3 dip. That is maybe the first hint of something that Contour provides, which is within the context of Contour, within the context of a Contour layout only, there is a int extension function which will convert integers and floats to the appropriate dip value. Something I also really like about this declaration mode is that you can have optional or lazy views, which is kind of neat. If you, for example, have a text view which represents a user status, you can actually look at the user as you're building the view, and if the status is null or not or just not set, you can just bypass creating that view altogether. So in simple cases, this is not a big deal. But if you have a view with tons of optional views that you're just setting to gone, this can actually be a really great optimization. It can speed up kind of heavy view initialization. So yeah, let's talk about initialization. But Contour is a layout library, so why don't we actually look into the mechanics of layout? So this is pretty much all done via a function, an extension function called apply layout. This is an extension function, again, only available within the context of a Contour layout, but it is upon any view. You call apply layout on a view, and this function takes in exactly 2 arguments. It takes in a x and a y. And the type of x and y is something called a solver. This answers basically 2 questions. Where should this view go, and how big should this view be? So to answer these questions, Contour provides a set, a simple DSL, a set of functions which can help you describe positioning and size. To start, you have something kind of the pattern of an edge 2, and then a lambda describing what you desire that to be. So left 2, right 2, top 2. You can do center vertically 2. You can do baseline 2 if you want to align text. Yeah, so for example, if you wanted to have a view aligned, if you wanted a view's left edge to be aligned to something, you'd define left 2, and then the edge you're interested in, or the alignment you're interested in. Sorry. Yeah. What's interesting about these is at first glance maybe they look like just kind of a shallow Kotlin DSL, maybe even they're inline lambdas, but these stick around at runtime and are executed at runtime. What is interesting about this is that this gives you the chance to make interesting decisions based on layout, on state during layout. And additionally, these solvers can actually give us information as well. For one, they can expose parent geometry. You could align your left edge to your parent's left edge or to your parent's center, something like this. Or you can also align to another view within the layout. So you can set up your view to be positioned referential to another view in the layout. Contour does quite little, actually, but the one guarantee it provides is that by the time these functions return, the layout you are referencing is guaranteed to be complete. Or if it's not possible, it'll throw like an appropriate exception, tell you what you've done wrong. What I especially like about these functions and this DSL is that the returned values are simple integer wrappers. So you can really just use any old operator you want to start defining your layout logic. If you wanted to position to your parent's top, plus some padding. I mean, you can just set a dip value of 15, reference your parent top plus some value. Or if you wanted to like center vertically to your parent's height, to a quarter of your parent's height, you could just take that height and divide by 4. So it's like really like kind of exposing just like basic math in your layout. An additional kind of cool aspect of this framework is these integer wrappers, in fact, are returned as types xint and yint. And what this actually gives us is like an axis level type safety. So you can't really like do anything that doesn't make sense. Like if you were to try to left align to the top of your parent, that doesn't make sense. So that'll be a compile error. Likewise, if you want to baseline align your text to the left of something, that doesn't make sense. These types, xint and yint, are they're implemented using inline classes, which is a Kotlin 1.3 feature, and it's pretty sweet actually. It basically gives us like a zero-cost abstraction. These types effectively compile down to plain integers, to like just like unwrapped integers. But at compile time, they provide us this extra kind of level of type safety. So we've kind of talked a lot about positioning. So let's talk about size. So you can then change these solvers together, and in this way you can start to declare size along an axis. This can be done explicitly or implicitly. So for example, if you've left aligned on the top example here, if you've left aligned something, you can then chain to that. You can call right to, and then this will basically guarantee your left edges to one thing, your right edges into another, and Contour will just figure out the in between. Alternatively, you can just say like, okay, I just want my view to be this height exactly in dip or referencing some other view. An additionally kind of cool thing about this DSL is that the functions return an interface which is kind of like a window to the correct actions. So it's a little bit different from a regular Fluent API. In the example here, if we are calling top to our parent's top, it doesn't really make sense to then again call top to or to call left to or something like that. So Contour, these functions will actually return just an interface exposing the correct actions. So you can get a pretty nice like autocomplete workflow, and it's pretty hard to do anything that's like crazy. The actions that make sense are kind of the only actions provided to you. So yeah, when you put it all together, this is kind of how we've been defining views in Contour. You call the constructor, pass in context. Using the apply function, you bind the data you're interested in. You apply styling, and then you set up your layout rules with apply layout. So people have asked before. Maybe you were asking, is this like a cheap Kotlin wrapper around constraint layout? Left to avatar.left, maybe looks quite a bit like layout constraint left to left of avatar. Is this the same thing? Are we really providing any value here? And I think to answer this, Kotlin's motivation is not to mimic constraint, but instead to provide a simpler layout API. It is in fact to encourage the use of just simple math expressions to define layout. So when I'm talking about like left to avatar.left, instead of thinking of constraints, really think of it as expressions. Really what I want is like left to be equal to avatar left. The main goal of Contour is to simply be the thinnest possible wrapper around the existing layout APIs in Android, and to encourage you to really just like do the basic math. So yeah, my argument for doing math is that it is really easy. If you look at almost any layout in like any application, short of like some very weird ones, everything is going to basically break down into a series of rectangles. And it's crazy. Like this is super easy, simple stuff. Like this is math that we've learned in grade school a long time ago. And abstractions like constraint layout and relative layout, they do give us some handy shortcuts. They can be nice at times. But what I don't like about them is they are fundamentally more complex abstractions, and this can lead to pain. This can be pretty sad for productivity sometimes. In one way, I feel like there's black box debugging. I don't know if anyone else has shared this experience, but I've like found myself many times using constraint layout or relative layout, and just like the thing's not going where I want to, and I'm like on Stack Overflow. I'm like, what the hell is going on? And then like someone like 15 comments down is like, yeah, there's some like magic word you need to use. So that's frustrating. You can dive into that layout, but it's not always obvious how it works. Performance can also be kind of unpredictable. Sometimes you don't really know what's underneath you. Constraint layout's pretty good. It's pretty consistent. Relative layout was kind of notorious for being not the best for performance sometimes, especially when it's nested. It was a multi-pass layout, and as you nested them, I think it would actually like require more and more passes. And then additionally, there's like kind of opaque rule sets that come along with these things. Like why, I don't know. Well, I'm going to go into some examples later, but like sometimes it just feels like you need to like wave your wand. It feels like there's like a magic word you need to apply in order to like make the thing actually work. So that's kind of crappy. Okay, I've been talking a lot, so let's look at an example. This is to me, this feels like a very common UI pattern that Lego designers will give us, maybe in a chat app of some sort. Let's just say you have like some view you want to represent. It's like going to be a row with like an avatar on the left. You want like a name on top and like a status below, and maybe you want that name and status to be centrally aligned. So for this example, I'm actually going to ignore the avatar because that part is so simple. I'm just going to focus on the name and the status. But kind of as we're learning Android, like maybe the first approach you're going to take is you'll wrap these things. You'll add them in a linear layout, and that looks a little like this. You add them in a linear layout. You center that linear layout outside in a outside layout, and yeah, that kind of works. It's pretty easy to write and to grok. I actually don't hate this approach, but it does have some drawbacks, and depending on how much you do this, it can be bad. For one thing, you're adding unnecessary views to the hierarchy. In small amounts, this is not a big deal, but in larger amounts, it can be problematic. So yeah, it can be abused. It can be bad. Additionally, this is like kind of inflexible. If we go back to this, if we want to add like maybe a status icon or something to the right of the status or to the left or whatever, your only option really is to like add another linear layout inside of the previous linear layout and make that horizontal, and then that's kind of how you make that effect. And this is fine, but as you do this more and more and more, you might start to get into like sad performance time woes. And even if it's not like super affecting your runtime, sometimes I find that like overly nested hierarchies, they just become like a cognitive load when you're looking at these things. Like if you have like a 15 deep layout, like when you're looking at that as a developer, you're just like, what is going on here? So it's not always about runtime. It's sometimes about cognitive load. Yeah. Then constraint layout was introduced. It gave us a lot of benefits. It kind of gave us more flexibility and an abstraction that let's do like some kind of more ad hoc positioning. So the typical approach for doing this is you'll take your two views, your name view and your status view below, and there's kind of this weird like contradictory constraint you have to set up. But basically, you like tell your top view, the name view, to align to the parent top, and then you tell it to constrain to the bottom view, to the status. Then you tell your status view to constrain to the top, to the name, and to the bottom of the parent. So you kind of have this like sort of constraint set up. But yeah, that actually doesn't work. It turns out that when you do that, the two views just kind of like float like separately in your constraint layout. So yes, there's a magic word you have to remember. You have to call packed, and then that'll tell constraint layout like, okay, we actually want these two things to like be together. That kind of gives us this, and okay, we've solved our problem. Yeah. constraints are better. There's no redundant views. It's reasonably fast. Things I've really disliked about it for a long time is a kind of unintuitive API. For some reason, when we're trying to center stuff, we're just supposed to have contradictory constraints, and we just I don't know, we just hope that the constraint layout figures it out. And there's that magic word problem where you just assign chain style to be packed, and that just makes the thing we want to happen. So Contour is all about doing this with expressions. And this is basically that same layout described in Contour. Really what you're doing is you're trying to take that same, for me, that same mental model that linear layout had of grouping these two things together, and then centering based on that. So how do you do this? Well, again, it's very trivial math. How do you center these two things in a larger layout? Well, it's the sum of their height divided by 2. You subtract that from the center of your view. Done. That's your top name view Y position. You then set up your bottom status view to just align with the bottom of the name, and you're done. So it has similar benefits of constraint layout in that there are no redundant views. It's reasonably fast. Something I additionally like is that there's less implicit knowledge. When you're just using simple math expressions, it just it's all there. It's been there for a long time. But maybe some of you are thinking this seems kind of awkward. This is maybe a little complicated for a simple example. But yeah, I think Contour is one of those technologies where I don't know. In my opinion, there's kind of there's technologies where they're really good at writing to-do lists and hello world apps, but then when you actually build them up into something complicated, they kind of suck. And then there's other technologies SQL jumps to mind, where it's kind of awkward and hard, but as you do more complicated stuff, you're oh, this is actually pretty well thought out. So yeah, I hope that Contour is kind of in this same category of as the problem set scales up, this technology makes sense and scales with it. So one cool feature that Contour does really well also is cyclical layouts, and you see this a lot in chat applications. For example, let's say you have a view with some avatar on the left, and then some freeform text where it could be a small amount of text, or the user could have written a paragraph, and it's going to be a ton. And really, what you want is you want this view to wrap the avatar, or if the text gets larger, then you want it to kind of expand with that text. So we can describe the thing first by declaring our avatar view. This is actually a pretty boring declaration. We basically just align it to the left of our parent, to the top of our parent with some padding, and just hard code a width and a height. The really kind of nuts and bolts, the interesting part of this comes with text. And this is the variable part. And the cyclical relationship here is this. It's that, okay, what defines the width of our text? Well, that's kind of the width of the parent. But what defines the height of the parent? Well, that's kind of the height of the inner child. So there's this two-way relationship, which is a little bit weird. Yeah. So if we jump back to our descriptive text, to our chat text, we align it to the left of our avatar with some padding. We align it to the right of our parent with minus some padding, and then to the top of our parent. But we need the parent to kind of react to these changes in content of text. And to do this, Contour provides the Contour layout itself takes in a type of solver, which can describe the height and width of the layout itself. So if we jump back to this, for example, we wanted to define this with simple expression, how would you do this? The height of the parent should either be, the height of the avatar or the height of the text, whichever is larger, the max, I guess. And it turns out you can define that by using max. You can compare which one is larger, the avatar bottom or the text bottom, plus some padding, and that's how you define the height of your Contour layout. So when you plug in that code, you get this kind of effect. This expanding row. You can make stuff even more complicated using comparative layout. Lots of chat applications typically have a timestamp, something to indicate when this message was sent. And maybe we have like rules where, like, let's say if the text is very small, you want that timestamp to, at the very least, align with the bottom of the avatar. But if the text expands, we want the top of that timestamp then to like come down with the text. So when we're describing this, we declare the view here, and we set up the contour. We apply layout, but it gets a little bit tricky, even more so now, because we're actually talking about comparing different edges. The right is pretty simple. We align the right with the parent, but we also want to have the top be able to either like match the description bottom, the freeform text bottom, or have the bottom of the timestamp align with the bottom of the avatar, like this kind of relationship. So how do we do this? And the interesting thing about solvers is that they themselves are comparable. So you can actually plug these into a max of and min of function itself. This will execute both solvers. It'll produce a new solver. It'll take the largest, and then that is basically what's going to drive the layout of that view. So it can do kind of has like neat little party tricks like this. So it gives you, like, when you plug that in, that gives you kind of this sort of interesting layout. So really, this talk and this library, I think, is kind of an argument for doing math-driven layout. And I think the key idea here is that this is not a very hard problem space. We've all been able to do this for a long time, but we just like made it seem harder than it was. Most layout abstractions are handy in simple cases, but as you get more and more complex, they can get really, really gross. I'm sure like everyone has that like God object kind of view in their application where there's just like a million constraints and you don't really want to touch anything anymore. I think this makes stuff a little bit better when you're in that world. And with math-driven layouts, you can also just like build the abstractions you need. So you can start with like basics and build up your world. So yeah, Contour is a solution to program, to declare views in this way. But it's actually an incredibly simple wrapper. Nothing's stopping you from just like using the underlying layout APIs yourself. It's all been there. It's basically all been there from like version 1 of Android. So just jumping back a little bit to like what Contour is and what it abandons. Like I've talked a little bit about like how I think the world is better without XML, just working in pure Kotlin, and like how Contour can be like a kind of nice alternative to constraint and relative layouts. But there's also one more thing just to like really beat it in. By living in this world, XML binding and tooling can almost be completely eliminated, which is like makes me so happy. These are like all the things you really don't need in your world anymore when you use Contour. The layout inflator class is like done. You don't need this. Those like weird r.id classes, you don't need those anymore. And with that, actually, you don't have ID collisions anymore because like you're just working in Kotlin. It's like it's a namespace language. You don't have missing resource inflation exceptions anymore. No find view by ID. You don't have class cast exceptions anymore. Like you're in a static language. Like the world's just static. Like the compiler will just catch it for you. And I think my favorite is like we're not dealing with this like laggy XML editor anymore. I know that like the Google team has done like a great job of improving this. But I think we've all been in that place where we're like in the XML editor and it's like just moving like frozen molasses. So we can just operate in a plain Kotlin editor and it's great. Yeah. So takeaways. I think that we should think more about UI technology. We've kind of been doing the same thing for a long time. But I think we should move into a more dynamic world. If, for example, you're doing like A/B testing, or if you're have views which are highly stateful, which kind of configure based on the current like piece of data they're supposed to represent. This is a really great way forward. Additionally, the problem space is like super duper simple. I think we're making our lives too hard sometimes because we're trying to be fancy. And then, yeah, finally, XML is like a static declaration method. I'd say it's not even really a good way of serializing data, and it's a terrible way of defining views. So we should use like a dynamic way. We should use like Kotlin DSLs or whatever like good full languages exist, which we can like use to describe our views in our apps. Yeah, so that's pretty much everything I got. So thank you for taking the time. Yeah.